The scatter diagram shows the data from a large data set for 80 countries, the life expectancy at birth against the birth rate per 1,000. The correlation coefficient between life expectancy at birth and birth rate per 1,000 is minus 0.743. The critical value for a two-tailed test for correlation at the 5% level is 0.220, displaying whether or not there is evidence of correlation. A spreadsheet gives the following linear model for 80 countries. Birth rate per 1,000 is equal to 79.12 minus 0.82 times life expectancy at birth. And 81st country, Peru, has a life expectancy at birth of 73.23. Use a linear model to estimate the birth rate per 1,000 for Peru. So if we were to conduct the test, and this bit you don't need to write down in your response, we will be doing this. H0 is rho, i.e. the population linear coefficient will be equal to 0, i.e. no correlation. H1 is that rho is not equal to 0, it is a two-tailed test. Therefore, as the critical value is minus 0.220, it have to be minus because we've got sort of negative correlation here, and minus 0.743 is less than minus 0.220, then there is sufficient evidence for H1 of correlation. So you just need to write this bit down in your exam script. B, if we add an x and a y, we will know that y is equal to 79.12 minus 0.82 times x. So if we substitute our value of x in, so for Peru, y will be equal to 79.12 minus 0.82 times 73.23, which gives a value of 19.07. Therefore, the birth rate per 1,000 for Peru per 1,000 is 19.1, correct to three significant figures. Then we're given this table of values. We have to determine whether the table of values gives any outliers, justifying our answer, justify any answer. So we need to find the lower bound for an outlier. So that when it's represented like this, we've got lower quartile and upper quartile, then it's going to be the lower quartile minus 1.5 times the interquartile range, which is Q3 minus Q1. So Q1 from the data is 72.465 minus 1.5 times the upper quartile, which is 78.915, minus the lower quartile, which is 72.465. On the calculator, that gives you 62.79. So we now take the minimum value here. So as the minimum value is 50.49 from the table, which is less than 62.79, then it is going to be considered as an outlier. The upper bound is going to be Q3 plus 1.5 times the interquartile range. So Q3 is 78.915 plus 1.5 times 78.915 minus 72.465, which is going to give 88.59. So as the maximum value of 89.59 is greater than 88.59, it is going to be considered as an outlier. So this has been a video to show you about correlation and then calculating outliers. I hope you've understood, and I thank you very much for watching.